Hello and welcome back to the Science and Engineering Practices Teacher Toolkit. This toolkit will focus on Science and Engineering Practice 2. Remember that the goal of these toolkits are to assist teachers as you begin to implement the new K-12 science framework for science and education in your classrooms. And I hope to help you identify areas in the current practices that correlate to science and engineering practices, as well as develop assessments that address each in science and engineering practice. Again, there's 8 science and engineering practices that are essential to developing proficiency skills in one's students, and the focus of this toolkit is Science and Engineering Practice 2, Developing and Using Models. Models are used in science and engineering to assist in analyzing complex systems. In science, models are used to develop explanations about natural phenomena, while engineers use models to analyze flaws in existing systems or to test possible solutions to new problems. As with all of the practices and with all learning, this practice builds on previous experiences throughout one's life. In grades K through 2, a student should develop the ability to develop models by identifying the similarities and differences between models and actual objects. By grades 3 through 5, they should be able to identify limitations of models so that they can build, use, and revise these models of scientific principles. Students in grades 6 through 8 progress to developing, using, and revising models to describe, test, and predict more abstract phenomena and to design systems. Throughout grades 9 through 12, students incorporate analyzing variables to predict and show relationships between components of natural and designed systems. Assessments that address science and engineering practice developing and using models would include terms such as simulate, represent, interpret, and develop. In this example, the NAEP Predicting Weather from Cloud Type, grade 4 item, was aligned by Montana teachers to be in best agreement with the Science K-12 frameworks K through 2 grade band. K2 students must have developed a working mental model of cloud formations and conditions associated with each in order to answer this question correctly. Students must apply conceptual knowledge, which places this assessment example at depth of knowledge level 1. This NAEP grade 8 recognized the direction of force of friction item was aligned by Montana teachers to be most appropriate and in agreement to the Science K-12 framework's 3rd through 5th grade band. This sample question is, like the K-2 sample, geared towards using rather than developing models, but the students again need to have developed working mental models. In this case, the mental model is centered around forces and motion rather than cloud formations, but the processes needed to develop these mental models are similar. Students learn new vocabulary terms, develop these terms, and they're made concrete through real-world examples, and the terms can be used to develop associated mental models. Students can then access these mental models in order to interpret models represented by other means. This is rated by NAEP as a hard question since over 60% of 8th grade students answered this question incorrectly, but Montana teachers rated this as a depth of knowledge level 2 for grades 3 through 5. Now this NAEP model of solar system, grade 12 item, was aligned by Montana teachers to be in best agreement with the Science K-12 framework's 6 through 8 grade band. Therefore, by grade 8, students should be able to develop physical models from data presented. In this NAEP, identify a portion of the Earth's carbon cycle driven by an internal energy source, grade 12 item. Montana teachers thought this question was best aligned to the K-12 Science Framework's 9-12 grade band. As students develop the ability to differentiate among more complex systems, their ability to analyze these complex models also develops. This question is relatively easy if one has a working mental model of Earth's structure and the ability to identify the relevant details in the model. This is a middle school lesson on watersheds, but the activities can easily be modified for all grade levels. The link to this lesson is on the main page of the Next Generation Science Standards under the Implementation tab and the Resources link, and then the Classroom Sample Task PDF. Well, thank you. That's it for Science and Engineering Practice 2, Developing and Using Models.